Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Welcome to ARC's For Your Innovation podcast. Today we have an exciting episode. We're going to talk about the founding story of Replit, the future of AI, and what the future of software engineering might look like. And so just to start, if you wouldn't mind, just introduce yourself and maybe talk about your company and the founding story.
Sure. Yeah, my name is Amjad Masad. I am the CEO and co-founder of Replit. Replit is it's the most ubiquitous programming environment in the world. Basically, it runs everywhere. Anyone can use it. It can run on your phone. It can run in the browser. It can run on your Peloton. I don't think we have a lot of coders on the Peloton, but our vision is that your programming could and should be a lot more accessible. And a lot of the things that software engineers deal with is sort of a story of Stockholm syndrome. So a lot of the tooling that we have is so difficult to use, and not because of any intrinsic problem of the technology. It's largely just like a bad sort of local maxima that sort of the development world has sort of settled on. So the main problem most people are familiar with, if you've taken computer science 101, and basically this is where the idea came from. I was back in Jordan, where I'm from, in Amman. I'm like 19, 20-year-old. I'm taking computer science, getting into all these different languages, Java, Python, what have you, depending on the class. And every time I want to do a bit of homework, I go to the computer lab and I have to set up the programming environment over and over again. Like download a gigabyte NetBeans IDE, try to configure that. You're missing a DLL, go in Stack Overflow, find that. So everyone's familiar with that pain. Anyone who's tried to do a bit of programming know that just to get to the point where you're typing out code is actually quite difficult. And then God forbid you want to share that program with someone, they're going to have the same problem. They might have missing packages. And, at the time, people were just like sharing programs over email. GitHub, I think, was just getting started. But even that wasn't like a lot better, right? Like you put up something on GitHub and then how do you actually run it? And so it was pretty obvious to me that there needs to be a browser programming and runtime environment that was reproducible, that was instant, that could run from anywhere with zero setup. So really the main idea and the vision was from day zero, not even day one, because this is like really pre-starting the company or the product. And so I built a prototype back then, and it started going viral in my university, which is like, it was just like a simple web page, and you could like select the language and type a bit of code, run it, and then like share it with someone else. I was like, okay, this thing has legs. Now, when it had all these, like JavaScript ran natively in the browser. And so, the first language was JavaScript. I wrote Lisp interpreters and whatnot. But when the time came to add like a real programming language like Python, that turned out to be quite difficult. So it took me 2 years, and eventually we had a bit of a breakthrough where we were the first to compile a bunch of languages to JavaScript. So we compiled Python, Ruby, and now this is like standard procedure with WASM. But at the time there was no WASM, there was no ASM.js. There was this research project from Mozilla, and it was in its infancy. And the idea behind it was that you can take the LLV. I don't know how deep we want to go technically. Seems like a technical
Go as
podcast,
deep
but
as you want.
so basically, there's the compiler toolchain called LLVM from Apple, and it has this thing called the IR language, intermediate representation. So this language is low level language, click above machine code, and it allows you to cross compile to a lot of different architectures. So if you squint, it kind of looks like a JavaScript or a C-like language. It is just a bunch of if statements and for loops. It's very simple Turing complete sort of language. And so you compile the Python interpreter that's written in C into the LLVM IR, and then you do a transpilation into JavaScript, and then you can run it in the browser. That's the sort of the simplest case. There's so much problems that comes with that. But anyways, we had this bit of a breakthrough. We put this project up on Hacker News. It went absolutely viral. And so, I was like maybe 22 at the time, and in Jordan, and then the inventor of JavaScript, Brendan Eich, was tweeting about this project, and it was like, it was like really exciting for me. And people started talking about it, and then I started getting job offers from the US. I joined Code Academy as the founding engineer. Code Academy, one of the largest online code schools, just exited for $500 million earlier this year. And I came to the US. They got me an O1 visa. I came to New York. I spent a couple of years at Code Academy. And then after Code Academy, I went to work at Facebook. And the reason I went to work at Facebook is because I was craving a deeper technical challenge. And Zuck was starting to talk about internet.org. If you remember that, it was like this idea, like, let's connect the world. It was like, Google had a project like that as well. Facebook's one seemed more practical. It's not like balloons or whatever Google was doing. It was like, let's get partnerships with telcos. Let's make Android as a computing device like a lot more accessible, cheaper, and let's make sure so that everyone in the world that can afford a cheap Android device can have like a free data plan. And so I joined that. The first joined Facebook to join that, but the problem was like I started doing Android programming, and I was like, wow, this really sucks. So you're writing this Java code, and you're waiting 15 minutes for the thing to compile. And I was like, I'm used to web development. I write a bit of JavaScript. I just like in like a second, I see it running in the browser. And I really wanted to solve this problem. Is like, how can we make Android more programmable, or mobile in general? So I started prototyping some ideas. Turns out there's an effort inside the company to bring web development to native iOS and Android. And that was bringing React.js, the framework from Facebook, to native, so React Native. And so I joined as one of the early engineers on that project. And it took us, a couple of years. We shipped in 2015. It was now it's like the biggest cross-platform mobile framework, and that was a lot of fun. In 2016, my wife and I, we always work on projects together. She's a designer. We were like looking for something new. Like my time at Facebook was kind of coming to a natural conclusion. I'm a very like sort of mission-oriented person, and so just like don't like wander and find something else. But it was like, okay, we shipped this thing. It's cool. People are using it. What else can we do? And the question back then in our minds was like, what happened to this online coding space? Like, let's take a look at it. And then you look, and there's like a bunch of online IDEs, and they're not super compelling. They're all sort of struggling. And the reason is, it's sort of, they take this like thing that worked on desktop, this very heavy duty program, and they sort of stick it in the browser. It is sort of like, when I remember reading about when the TV first came around, you had the first TV program was someone reading a book on television on camera. Instead of like they were doing the same thing they were doing with radio, but in a different medium. And like every medium shift, and I think, Marshall McLuhan, these kind of philosophers talked a lot about it, is every medium shift at first is like, you don't have the native media for that medium just yet. And it takes a long time for that to evolve. Like, I mean, if you think about television, like just now we're starting to see the native television media, which is the Netflix style kind of subscription media. And for programming on the web and the cloud in a collaborative way, a lot of the efforts in the like early aughts were just like really just like doing the same thing. They just put it in the browser. And so with Replit, when we started Replit in 2016, the idea was that we want to build something web native, and that meant we need to rethink every part of the architecture of software development so that everything is like deep linked, everything is collaborative, and on top of that, we have like a really fun and engaging community. And the idea was that okay, the go to market strategy was that this thing is gonna be toyish for a long time, and so maybe we're not going to be able to get the professional developers, but let's get the students, the kids, the teachers, the hobbyists, the misfits on this platform, and grow from there. And we've been executing on this since then. Now we have 17 million registered users all over the world. They build projects that get 30 billion hits a month on the platform. So we're operating on a really large scale right now. And we're starting to move up market. We're starting to see developers switch their entire toolkit. Maybe we're not entirely ready for that, but I think next year we're going to see a lot of developers just adopt Replit as their primary, not only just development, but also hosting a runtime environment. And really our mission is to power the next generation software development. And we're building something that is collaborative by default, instant, ubiquitous, and AI powered. And I'm sure we're going to get into especially the AI part in a bit.
Yeah, it makes a lot of sense, especially for people who are just getting into software development. The barriers to entry are pretty high, and that like just getting an IDE set up is in and of itself kind of a complicated thing. And I think that in and of itself kind of scares people away. And so the easier it is to get started, the more people I think will be drawn to software engineering. That makes a lot of sense. For the professional software developer that already has an IDE, right? They've got their toolkit. Why do they move to Replit? What pulls them over from just like an incentive standpoint?
Yeah, the typical path is like, programmers are special in that their hobby is programming in addition to being their job. So, like a plumber doesn't do plumbing in the weekend. It's a very unique thing that a programmer maybe they
Maybe
do.
someone does, but yeah, certainly the exception, not the rule.
So programmers tend to play with things on the weekend, right? And we see a lot of like senior programmers get the value of Replit really intrinsically because you have to understand programming was a lot simpler, was more interactive in the 70s, 80s, 90s than it is today, right? So, kids who grew up with basic terminals, with Commodore 64, they get Replit instinctively because it's like, oh wow, like I can go there and just type code and it just works. And so that's how we get a lot of adoption is that like a lot of people just use it, although they're professionals, they do more hobbyist project. And then it starts eating into the workflow. Like we see it just like, oh, I'm going to use it to like share program during work. And then they share program at work. And then that person signs up and then they start using it. And it has this viral growth. And I think any web app that's deeply linkable is inherently viral. And you saw that with Figma and how Figma infected organizations, not just designers. I think the stats came out where 40% of the MAUs on Figma are designers. So that means 60% of the MAUs are non-designers using a design tool. And so this is what happens when you make something with a low floor and high ceiling is that not only you're going to get the professionals, but you're also going to expand the TAM tremendously and start getting like non-programmers, technical people also involved in the process of making software.
That's a good transition to AI and the capabilities that we're seeing evolve in code generation. I'm curious, how are you guys thinking about incorporating AI in the short term? I know you've already announced some products with kind of AI features and functionality. How are you thinking about that in the short term? And then we'll touch on the long term.
Just to back up a little bit and just to talk about it from first principles, code, we've always had tools that operate on code, right? Like, so code that like works on code. And at Replit, we're sort of a company that specializes in running code and parsing code and using code as data, right? So this idea of code as data is not a new idea. It actually goes back to the 1950s when Lisp was invented. In Lisp, by the way, Lisp is also the inspiration for Replit because Replit comes from the root word REPL, read eval print loop, which is a Lisp program that bootstraps an interactive programming environment. And in Lisp, the code is the data. So at an MIT AI lab in the 50s and 60s, they were trying to build AI. And one of the ideas that they had is that an AI needs to be self-reflective. So it needs to understand its code and be able to edit it. And so they had a very interesting idea, very ahead of its time. So, okay, this idea of code as data has been around for a long time. The problem is that applying ML in general to code as data, it was a very laborious and very specific task. So you would have to train a model to do one specific task, for example, refactoring or autocomplete. And there were some attempts, especially starting to last decade, you had Kite, which just announced that they were shutting down. And you had a few startups that were starting to kind of think about the idea of applying NLP and especially deep NLP, ML style NLP to code. And they had some initial traction and success. Now, the problem with all these things is the lack of generality. Like every time you want to add a feature, you have to retrain and you have to retrain for that specific feature. You have to create a benchmark for that feature. It's just a very laborious, ops heavy kind of task. Then you had the big change is the transformer revolution. So 2017 research lab at Google announced Transformer. Transformer is this new neural network architecture. And the first sort of place they applied it is this language model called BERT. And then they rewrote Google search using BERT. And Google search got a lot better and started understanding intent better. And that is because the transformer, and especially applied to natural language processing, is a very powerful tool. And it requires less work on engineers and researchers to train this thing. You can train transformers in a unsupervised way. So the way, say, GPT, which is the largest brand name in transformer technology, is trained. GPT-3, for example, is trained by taking the entire internet and training the transformer on it. And the way it trains itself is by masking tokens or by masking words. You can think of it as masking words. Basically, you put in training batch. Let's say you put in a sentence, and it looks at the sentence, it masks the last word, and starts to try to guess the last word. And by learning how to guess words, it learns the structure of language. And now what OpenAI found is that when you scale these parameters up, parameters are the sort of weights and biases inside the neural network. So when you add more layers to the neural network, to the kind of multi-layer perceptron, you get more and more intelligence. And so BERT was like a couple 100 million parameters. That's the one that Google productionized. GPT-2 was 2 billion parameter, I think. GPT-3 was 175 billion parameter. There's a lot of speculation about what GPT-4 is going to be, but definitely it's going to be more parameters. And then you had these emergent behavior happening where these models understand the structure of language, have some reasoning capability, have some basic arithmetic capability, have some coding capability, have some basic logic capability. And the more you train them, the more you scale them up, the better they're doing. And so now the difference is you have a model, and that's why they call it like a foundation model, that is pre-trained on an existing corpus, and has this amazing capability right at the door, even without applying it to a certain domain, even without training it for a certain domain. It already comes pretty competent with that in that domain, and then you can fine tune it for that domain. For example, for code, turns out that the moment they announced GPT-3, people start playing around GPT-3 for code, and it can generate entire HTML pages by telling it like, hey, like make me a website that does X, Y, and Z. And the way you program transformers is by prompting them. And so prompting is a natural language technique to get the transformer or to get the language model to tell you to learn something on the fly. So they call it in-context learning. So again, now let me recap. We had ML models that were very specific, and now we have ML models that are foundational and have in-context learning. So we have ML models that are programmable. So this is, if you think back to the early computer revolution, computers were, fixed program computers. Like you would design a computer to do one task. And then, what people call von Neumann machine, or, a better kind of description for it is the stored program machine, as the idea was that, okay, now the machine can be programmable without changing the architecture of the machine. So now you create the software layer. So one way to think about transformers, like now we have the software layer for ML, because you can do in-context learning, few-shot learning, whatever people call it. Basically, you can take this model that's pre-trained and capable and then make it more domain-specific and have it really perform super well on certain domains without additional training. And so when it came to code, so, we had this idea that code is data. And what turns out is also code is very, very much like natural language. So large language models had a really good model of the world just based on language. Turns out they also learned how to code very well. And so now applying large language models into code became a viable thing. We started playing with it early on, starting with GPT-2 in 2019. We got some prototypes out in 2020. Microsoft, with their partnership with OpenAI, released Copilot in beta in 2021. We started working on sort of our own version of that. We released it earlier this year. It's called Ghostwriter. And Ghostwriter is a programming assistant, and it has two different modalities. So in one way, it completes your code. So think of the Gmail language complete. That gray text that comes out, and you hit tab, and that's very basic, by the way. Ghostwriter is a lot more advanced. It can understand the intent behind your code. And then the other modality is that you can right-click and do certain actions. For example, you can highlight a piece of code, right-click transform, and you can tell the AI, make this code faster, and it will generate a code that it thinks it might be faster. Of course, you still have to review that code, but you can also just say refactor that code. You can give it very vague instructions, and sometimes it'll figure out what to do.
Curious, if you look at the usage of that product today, GitHub released a study that was showing that on certain tasks, software engineers were able to complete a task in 50% of the time with Copilot versus without Copilot. Are you guys seeing kind of similar uplifts in productivity from usage of that product?
Yeah, we're yet to make a study. The study that I saw from Copilot was 30% better on time. But this is what users are reporting to us. They're like, this is saving me, and they're estimating this is saving me 30% of my time. I got something done in a day instead of 2, or, you can sort of start to get, okay, this is like a meaningful percentage uplift. But by the way, this is a very important point. There's this very famous book called The Mythical Man Month. Have you heard of that book?
I haven't, no.
So the Mythical Man Month was in the early days of software. The way people approach software was like a very, very much in the way you'd approach building a bridge. And a lot of physical engineering sort of scales with how much resources you put into it. So this guy Fred Brooks was working at IBM on the disastrous project that was OS 36. That I think took 10 years, and I think took 10 years to ship or something like that, some crazy number. I might be wrong about the details, but it was known as like one of the most disastrous software projects in history of software. And it really kind of was the catalyzing point of actually thinking for managers to really think, it's like, hey, we don't really know how to do software. And so this guy wrote this book, The Mythical Man Month. And for the title, what he's saying is that this idea that man and month is interchangeable. Today we'll say person and month is a myth. Like, you can't add more people to a project and expect it to go faster, get better. Today we know, Amazon, Jeff Bezos is known for the pizza test. If a team is larger than one order of pizza, then the team is probably dysfunctional. And so we know how little software teams can scale. And in that, he also talked about the limits to productivity. So there's an essay inside that book called No Silver Bullets. And he talks about how it is impossible to have a big lift in productivity for software engineers. Now, this prediction or this kind of thing that he said turned out to be quite prescient, but wrong in some cases. That there isn't a lot of things you could do to make programmers more productive. We had one thing, in the past 20 years that was probably like an order of magnitude productivity enhancing for engineers, and that's open source. So suddenly you have at your fingertips. And by the way, he foreshadows that in the book. He talks about libraries as potentially something that is a silver bullet. All of this to say is that I think we're in the inning of another silver bullet. I think we are starting to see productivity gains in software engineering that are on the same order of magnitude as open source was for software engineering.
I couldn't agree more. And in terms of how people are using AI today, how they're using your AI product, do you see it benefiting like an entry level hobbyist and a professional software developer the same, or do you think the benefit currently skews more in one direction?
Insofar we have limits, we get more hobbyist usage. The moment we solve these limits, typically we get more professional usage. And by the way, this is the case in every computing revolution. If you look back at the PC was seen as a toy by the people who used IBM iframes. It wasn't until the PC got good enough and got enough software and applications and power that it started eating upwards. And now you have entire data centers that are running on PC architecture. And so it ate the entire computer space. So this is the classic Clay Christensen's innovator's dilemma, right? And so we're going to just continue climbing up the power curve. And I think we're going to be able to get most software engineers in the world on Replit.
I mean, the same could be said of most technologies. Look at electric vehicles, right? That was a toy for the longest time. And now it's certainly. So thinking into the future, how is the role of a software engineer going to evolve? Is the role of a software engineer going to look the same 10 years from now, just with AI as a sort of an assistant? Or is the role going to fundamentally evolve into some sort of like prompt engineer, where your primary job just becomes interfacing with an AI tool?
I don't think prompt engineering is going to be a big thing in the future. I feel like people extrapolate too much from the present. Like, I feel like prompting is almost like a bug and not like a feature, because it's like very brittle and it is unexact. And it has all these problems like prompt injections and similar to SQL injections and things like that. So I don't know what will replace prompting, but I'm like pretty sure that's not going to be the primary interface. What I think we're going to be able to do is build agent-like software developers. Like, we're going to build AI software developers. I actually think it is possible using the current technology. It just requires a lot of investment, a lot of research, a lot of data, and a lot of capital. And I think we're going to be able to build it at Replit. But basically, like, I think the way software engineers will work in the future is that a lot of what they're doing is project management and code review, writing like deep, like like hot loop code, when you're like in a low level, language, and you're writing like a very performant piece of code. I don't think they'll be doing that. Most engineers, I think, will be just like giving tasks to different AIs, reviewing the code, merging things together, and just operating on a higher level. So if you think about the history of programming, it was, punch cards, or like machine code, punch cards, assembly, high level languages, C, dynamic languages, Python, and they sort of stopped, right? Like we haven't really crossed that barrier. And I think this is the S curve. And now the next catalyst for the next kind of S curve is that you're not typing as much code and you're operating on a more architecture level, and you're sort of designing, you're actually in a more creative space, and you are working with AIs and you're actually talking to them via language. So I agree with the idea that there's going to be some prompting, but it is not like the way we think about it today. It's more like chat. It's going to be more like dialogue. I think there's also going to be different languages. I think we're going to have DSLs. So DSLs is like domain specific languages that are particularly optimized for dealing with AIs that can generate code really well. And so you can imagine like the DSL becomes this really high level language that programmers are dealing with. And the compiler is sort of this AI that is able to take the DSL and translate it into full working software. I think software is going to be more accessible. I think we're going to have more software jobs. It's not like we're going to automate software, but a single software developer will have the same productivity level as like 100 software developers today.
When do you think we're going to get there?
So at Replit, we're working on Ghostwriter V2, which is Ghostwriter is our AI thing. We released a few weeks ago. It's growing 30% week over week.
That's insane, by the way.
Yeah.
30% week over week.
Yeah, it's really taking off. And we're working on Ghostwriter V2, and Ghostwriter V2 is gonna be more aware of your environment. So it knows your files. It can create and delete files for you. It can do entire tasks. It can fix errors for you. And I think we'll be able to get there next year, late next year. And that'll start to feel like like you have an assistant. I think once you can have like 50 assistants or 100 assistants, that's probably like more like 2026, 2027, where like, every developer will be 50, 100x more productive.
We do a research report every year. And last year we said that the average software engineer will see a 2.5x productivity uplift by 2030. And I think a lot of people outside of AI thought we were kind of crazy, and that wasn't true. And looking at the progress over the last year, I think we like severely underestimated the productivity uplift. So that's a reaffirming data point.
I like how you guys think at Arc. It's very unique, and it's like very first principles type thinking. I mean, when I listen to Kathy, I just get so excited about the future, and yet I think you're sort of underselling it for sure.
Yeah, I think we sit in definitely a contrarian box in many of these forecasts. If you look at just like general, I think we're contrarian on two levels. I think for AI in particular, if you talk to yourself or people at OpenAI, like we're contrarian in the sense that we're underestimating the potential. If you go talk to the average person on the street, we're contrarian in the sense that we're overestimating. And so I think we're in this kind of funny middle ground where the experts who are really leaning into the technologies in many cases think we're underestimating the potential. but I think people just haven't quite realized it. And it's this funny thing with humans, like we're not good at understanding exponential growth. And to your point, 30% week over week, I would have to do the math to figure out what that is on a sort of a multiple basis over 12 months. It's a huge number and it's completely non-intuitive. Like we looked at the sort of the cost declines in AI and found that historically costs to train a neural net to perform a specific task. In this case, I think it was like AlexNet performance declined at roughly 65% a year for like 8 years. And we continue that modeling work and think it's going to continue to decline at 60%. So if you look at what that means, if you have a 60% cost decline, the cost to train a model to GPT-3 level performance, and say GPT-3 costs $5 million to train in 2020, give or take, you get that same level of performance for $500 in compute in 2030, which is
Oh,
just
wow.
insane.
That's
And
amazing.
it's
I
just
saw, I
this.
think you published this thing. It was like there's a Moore's law in training, right? In training neural nets.
Yeah, it's
Yeah.
like Wright's law, right? Which is
Yeah.
there's Moore's law and Wright's law, and Wright's law is sort of the cousin. And instead of it being attached to time, it's attached to units of production. And so for AI, we just use GPUs as units of GPU produced, and we can sort of use that as a proxy for an overall cost decline and training efficiency. But it's one of those things where it's just hard for us as humans to grasp like exponential curves. But it works and it makes sense, and you can map all this stuff historically throughout history. We saw the most recent example being Tesla and the cost of electric vehicles. But Moore's law is the greatest example of all time. The cost of compute has just continued to collapse, and you could argue that it's maybe running into a wall a little bit. But regardless, it's incredible. And just we have a couple of minutes left, and I mean, just to close out, I wanted to touch on two things. First, as you think about like building moats around Replit, and how you build a dominant competitive position with AI in particular, it seems like some of these capabilities will be to some degree commoditized, right? If we're using foundation models from OpenAI or from others, and everybody has access to the same capability through an API, and you can maybe fine tune it a little bit, it seems like we're moving towards kind of some level of commoditization. On the other hand, like if you either train your own models or like you have a bunch of proprietary data to like really fine tune a model in a way that's unique or differentiated, you can kind of leverage your own data advantages. But curious as you really build this out and build out this vision of becoming not only the future platform for software engineering, but really enabling and unlocking all the potential of AI for software engineering. How do you think about competitive moats?
Yeah. Well, I know you guys are super Tesla bulls, and like you can look at Replit as similar to Tesla. The reason Tesla can be the leader in autonomy is because they have so many cars on the street collecting data for them every day, right? And that's one. Two, they are very well suited from a company DNA perspective, just being a software kind of enabled company, and from a platform perspective, just being a software in wheels, they are very well suited to deploy this technology, right? So a lot of the other companies will just play catch up just because they were never as computer driven as Tesla. Computers were always felt bolted on for any car like Mercedes or whatever. It just feels inelegant and it's not really the center of everything. And so with Replit, the platform is like peanut butter and chocolate with AI. For example, like when the AI generates import NumPy. If you're using VS Code, like you're gonna have to go install NumPy, figure out how to install NumPy. On Replit, we actually detect what the intent of the program is. That's also sort of another learned behavior, and we install it for you. And say the model generated code to show a graph. We also detect that, and we open a graphics window to show you a graph. None of that automatic behavior happened in any other IDE. And the reason is because we're this vertically integrated platform. And so when you plug AI, it just makes everything better and more powerful. And finally, I do think there's a data mode. Yeah, it's easy to overplay the data mode, like a lot of companies do. But, you know, like there isn't really another IDE on the market that's like fully vertically integrated, works in the browser, works anywhere, has as big of a user base as we do. And there's a flywheel effect. So you train a model, you deploy it, you get more users, you get more data, you deploy a model, you train another model, you deploy it, you get more users, data, and so that sort of there's this whole flywheel effect. And finally, I also believe in Elon's thing about moats, which is the only real moat ultimately is just being like 2, 3, 4, 5 years ahead. And we've always done that at Replit. Like we're still the leader in real-time collaboration. Nobody has caught up yet. We thought, like when we built it in 2018, we thought it would have like a 2-year lead. It turned out to be like a 4+ year lead. We'll see when GitHub has real-time collaboration. And I think we should just keep building those advantages.
Yeah, that makes a lot of sense. And I mean, the same as you could say is true with Figma, right? And they just stayed far enough ahead where Adobe couldn't catch up, and then it became like a serious competitive threat where if they didn't acquire them, they were going to crush, the core, design software business. And at the same time, it seems like with AI, to some degree, incumbents have an advantage. Not calling you an incumbent necessarily, but I think you're becoming the incumbent in the sense that like you are the platform that software engineers are migrating to, right? This is where software engineers want to actually code and collaborate. And that better positions you to build AI features than a net new product that's trying to now attract software engineers over to their ecosystem and their platform. And Figma using a proxy is like the same example, right? Like Figma is probably best positioned to deploy AI tools for design.
Yeah. So here's a contrarian prediction, because like a lot of VCs are now like, when they hopped on this like generative AI kind of train, which is kind of becoming really boring really quickly. There's like this buzzword now, AI native startups, um, which is like saying like native self-driving car. It's like, no, you need a Tesla to deploy self-driving on.
Yeah.
Like Waymo, I guess, is a native. Like when are they shipping? Never. And so with AI, right now, I think the horizontal tools and platforms will be the first to kind of deploy it and get a lot of benefit out of it. Not saying that there won't be like AI specific startups, but I think it's more like the startups that already have some usage and already have some growth, and they can react really quickly to the shift and build in the capability. They're going to be the winners, as opposed to like startups that have to build AI capability and get the users and build the platform and all of that.
I couldn't agree more. Yeah, there are many writing assistant startups that have been funded without naming any specific company. And same thesis there, right? I think it's going to go to the companies the Notions of the world that already have users using them as a writing tool. And it seems like there's AI first capabilities maybe for vertical AI, where you're building, I guess, in many ways, a vertical SaaS platform with embedded AI. But certainly seems like the advantage will go to those platforms that already have users using that for some native domain specific capability. But fascinating. And I know we're up on time, but one more rapid question for you. If you look back at your experience building Replit, what's the one thing you wish you knew from day one when you started the company?
To trust myself more. I think sort of at the risk of sounding arrogant, but I've been derailed mostly by just sort of like random advice from investors, from customers, from maybe even people that I consider mentors. I start to take a bit of a negative view on advice, because I think advice is very context sensitive, and like people extrapolate from their personal experience. So whenever someone gives you advice, take the meta view on that advice. It's like, what is the reason they're saying this? And does it apply to my situation? Because a lot of we like to think in Silicon Valley that we're like this, very analytic kind of group of people, but there's like so much pattern matching here, and there's so much cargo culting, and I wish I was more independent minded. My nature is independent minded, and even for me that wasn't enough. And I think just really, really being disciplined about trusting your instincts is super important.
That's great. Couldn't agree more. Awesome. Well, thank you so much for joining, and look forward to following the journey.
Awesome. Thanks a lot.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.